Using a silicon retina for playing card recognition, System 1, FFT based. Created and conducted at the 2010 Neuromorphic workshop in Telluride, Colorado.
Hi, my name's Dan Lofaro. I'm here at Telluride, Colorado at the Neuromorphic workshop, and I'm working on using a silicon retina right here to distinguish what card this is. So this right here is a silicon retina. It's different than a regular camera because it's event based. The only time a pixel or an image comes up is when the change in intensity of that pixel happens. So again, this is asynchronous, so there's no frame rate. It's just by per pixel basis. As soon as it changes, that is when the event comes. So it can be as fast as 200 kilohertz or as slow as however slow you want to get. So in this method, we have the silicon retina here, and we have right here the two of spades, which is going to fall down this little slide. As it falls down, silicon retina is going to read this. Again, this is important because the silicon retinas don't see anything that don't move because it needs to see a change in intensity. So I'm going to drop this down here, and then we're going to get an image back on the computer. We'll go there in a moment. Drop that down. Wonderful. Alright, let's go head over to the computer. Alright, I'm just going to zoom into the computer a little bit for us so we can see what's going on. There's the display of the not much happening on the computer at the moment. Alright. So, let's go play back that log data. Let's do open. Where's that autosave to? Alright. So here is, I need to start playing back the logged data. Let's slow it down just a little bit. So right here, you can see it is a two of spades moving down. Now, we can tell what it is, but how are we going to compute it to tell what it is? So this is already saved to the computer. So let's close this. Let's discard changes. And now we're going to open up MATLAB, where I have the rest of my software running. So right now, it's going to open up the open up the file that I just created. And so I'm going to run it. What it is doing is it's picking it apart piece by piece, and first it maps it in a three-dimensional space. So this sorry about that. So first, right here is the time that it recorded. This is the y-axis of the camera frame. This is the x-axis of the camera frame. The vertical axis is time. So if we look this way, we see that nothing much was happening here. Again, not many spikes. This is event-based. Whereas at this moment in time, a lot of things happen. If we take a look at it from the top, we plainly see the track that's falling down and a nice stripe where the spade was. Now the software also cuts it up to only look at where the actual event took place. So let's go open up that one. It was after this. There we go. So this is the actual event. So I'll make this bigger so we can all see. As you can see here, the vertical axis right here is time, and x, and y. So you can see the nice stripe. This is looking down on the x and y as the camera sees it. And this is the time view. Now this part is the interesting part. You can see, though there was only one card in time, you see two stripes. This is because there are two pips, or two clubs, on the card which streak across in time. So these are the features. This is one of the features that we're going to look for to tell what type of card it is. So this tells us how many rows of cards we have, and this right here will tell us how many columns. So to get a better picture of this, this is the y versus time we can actually count the stripes to see how many pips we have. And then here is the X versus time. And here is the top view, the XY. This is how we can get how many columns we have. Again, this is still a work in progress, but this is how I'm trying to use a silicon retina to tell what type of playing card we have.